This is the lesson for Chapter 9, Section 8, titled Systems of Linear and Quadratic Equations. And so the first type of problem we're going to end up seeing here is one where we have to graph or solve by graphing. So we're going to graph this quadratic. So when we graph quadratic and there is no b term, you'll see if I use this method here, I use the x equals negative b over 2a, the axis of symmetry method. And so you see there's no b term, so that's going to be 0. 0 over 2 times no matter what number I have. In this case, 1 makes 0. So this is my y-intercept and the vertex in this case. And so I'm going to go up 2 spaces, put a dot there, and then use the parent graph. So the parent graph is a y equals x squared. So it just means that I'm going to go over 1 space, up 1 space, over 2 spaces, up 4 spaces. So the points would be just a little above my graph. And so that's what the graph is going to end up looking like. And what we're going to be looking for is where the graph crosses the x-axis. And so we'll go ahead and take a look at where the graph crosses the line. And so let's take a look at this one. And this one is our linear equation. It's linear because it's to the first power. X is to the first power. So I have my y-intercept at positive 2. So there's one solution right there. And I'll do this in a different color so we can see a little better. So there's one solution. And then I use the slope. The slope of this line is 1 to 1. And so that tells me I need to go up 1 space and over 1 space to the right each time. So I do that a few times, and you see how I have some points on that line. And so you'll see that these 2 points are the solutions of our equation. So those are the ones I'm going to end up writing down. So negative 2 comma 0, and I also have 1 comma negative, or 1 comma positive 3. So 1 comma positive 3 is the other solution. So not negative 2 comma 0, that's a positive 2. So I must be looking at something else here. So let's go ahead and fix that. So fix those points there. And so this point is 0 over and 2 spaces up. And then I also have this point 1 space over 3 spaces up. So those are my 2 solutions of that system. So let's take a look at this next one. I've got a b term this time, so I'm going to use the axis of symmetry formula, negative b over 2a. And so it's going to be a positive 4, because the opposite of negative, over 2 times 1 makes 2. So I substitute back in, so to find the y component of the vertex, so 2 squared minus 4 times by 2, and then minus 2. So that makes 4 minus 8 minus 2. Makes negative 6. So I got to go down 6 spaces and then 2 spaces to the right. So this is just the vertex. And I find that by going, go over 2 spaces, down 6. So 1, 2, 3, 4, 5. So I'm going to have to make a point right there. But I see the parent graph is just an x squared. So it's going to go over 1, up 1. Over 2 spaces, up 4. So there's 1, 2, 3, 4. And look, it's crossing the y-axis, so let's take a look and see if it's about right. So yes, negative 2 is the y-intercept, so that matches what I have here. So I'll sketch that graph in and look at the next one. So the next graph is the linear equation, and it has a y-intercept of negative 2. So there's one of the solutions right there. And it's got a y-intercept of negative 1. So I'm going to go down 1 space and 1 to the right. So down 1, 1 to the right. Keep on doing that a few times, and look, there's another point where they cross. So those are the 2 solutions that I'm looking for here. So I go ahead and write those numbers in ordered pairs. So the solutions are 0, negative 2. That's one of them. And the other one is 1, 2, 3 spaces to the right and 5 spaces down, so negative 5. So those are my 2 solutions where the line crosses the quadratic. Let's take a look at another type of problem we'll see. We can also solve by elimination or substitution. Elimination works pretty well with these problems. I could use substitution by substituting this x squared minus 4 in for y. So I'm going to do actually both methods. So I'll do substitution with one, and I'll do elimination with the other. So this one I'll do substitution with. So I'm going to substitute in for this y right here. So it's x squared minus 4 equals negative x minus 2. So whenever I've got a quadratic, I solve a quadratic by setting it equal to 0 and trying to factor. That's what I'm going to end up trying to do. So I'm going to move the negative x back over to the left-hand side. So that's going to switch signs. And I'm going to move the 2 over. So I'm going to add it So adding 2 to negative 4 makes negative 2. So I can factor this. This does factor. So x minus 2, actually x plus 2, x minus 1. Positive 2, negative 1 multiply to make a negative 2. They subtract to make positive 1. So I need to use the zero product property, and I end up with x equals negative 2, and over here I set it equal to 0, I end up with x equals positive 1. So I'm not done yet. I still need to find out what y is for these two answers. So I'm going to plug negative 2 back in for x and come up with y. So y equals negative 2 and then opposite of negative 2, that is. Opposite of negative 2 minus 2. So plus positive there, so 2 minus 2 makes 0. So one of the points is negative 2 comma 0. And the other one, do the same equation there. It doesn't matter which equation, you get the same answer either way, because these are the points where the two graphs cross. So I'll just pick the linear one. Negative, the opposite of 1, minus 2 makes negative 3. So my point is 1 comma negative 3. So those are my two solutions. Let's take a look at the next one here. So this one I'll solve by elimination, so you can see which way you like better and kind of go with that. So I'm going to go ahead and multiply this one by negative 1, and I'll get the y's to cancel. So when I do that, I end up having negative y equals, now I'm going to move the 2x over so they're in line. So negative 2x plus 2. So I'll go ahead and add the two equations. So I'm adding this equation here and this one that I just modified. So the y's cancel out to make 0. I got x squared, and the negative 2x, negative x make a negative 3x, positive 2, negative 6 make a negative 4. So now it's ready to use the factoring method. So that's the difference, is you got to modify the equations, but when you do that, if y is by itself with both, you'll have it ready to factor once you get that far. So x minus 4, x plus 1 is the factored form. And so when I go ahead and solve my two equations, I end up with x equals 4. Over here, I end up having to subtract the 1, so I end up with negative 1 as the other solution. So I still need to solve, so I'll substitute in. So I'll use that top, or the linear equation. Y equals 2 times by 4 minus 2. So when I do that work, that gives me 8 minus 2 makes 6. And then the other one was y equals 2, and then I've got to multiply by negative 1, and then I'll take away 2. So negative 2 minus 2 makes negative 4. So here are my 2 points, 4 comma 6, that's one of them, and then negative 1, negative 4. That's the other. So let's take a look at the word problems that you'll end up seeing. So here's a couple examples. It says the weekly profits of two different companies selling similar items open for business at the same time are modeled by these equations below. The profit is represented by y. Okay, so y represents profit, so that's dollars. And number of weeks the companies have been in business is represented by x. X is weeks, and that's the number of weeks they're in business. According to the projections, what weeks did the companies have the same profit? Okay, same profit. That means we want to solve for what is the same, what points are the same for the two, and what was the profit for both companies during those weeks of equal profit. Alright, so you pick your method of solving. I'm going to use elimination with this one. I'm going to go ahead and multiply by negative 1. Just switches the signs. So negative 5x minus 65. So another way to do it is just subtract the two equations, or maybe just switch the signs and then go ahead and combine. And we end up with 0 equals x squared minus 20x, actually minus 120x. Got to add those two because they're the same sign there. And then here I have to subtract these two numbers, and I end up getting 3,276. So this is a tough problem. I'm going to go ahead and I'm not going to try to factor this. I'm going to go ahead and use quadratic formula. It will factor, it's just that quadratic formula is going to be a lot easier. So I substitute the numbers in. So here's what I'm going to have. I'm going to have a positive 120 because it's the opposite of b. And then I'm going to have two equations. So I've got the plus and minus, the square root of, and then 120 squared minus 4 times by a, A is 1, times by C is 3,276. And then down below, I end up with 2 times by 1. So I've got these two equations I'm setting up. So let's go ahead and take a look at how I'll punch that into the calculator here. So I'll move the calculator down so I can see the equation. And we'll start by using the fraction button. So I'm going to use that fraction button and start entering the numbers. So I got to do one at a time here. So I got 120. I'm going to enter the plus sign and the radical sign. Now when I do this, I'm going to do 120 squared. So I press the squared button, and then I'm going to press minus. Now I want to make sure I get the 4, the 1, and the 3,276 to multiply together first. So I'm going to go ahead and overuse some grouping symbols here. Don't really need to do this, but I'm just going to make sure it works. So 4 times by 1, and I didn't really need the times by 1 because that's not going to change anything, but I just put it in there anyhow. 3,276, and then I'll close those parentheses. And now I'm going to go down into the denominator and just write down 2, because I know 2 times 1 is 2. So let's go ahead and see what answer we get. 78. That's the right answer there. So I'm going to go ahead and write that number in here. So 78 was one of the solutions. Now this is an x value. X represents weeks. So that's going to be weeks. And let's find the other value. And so let's go back to the calculator. And on the calculator, what we can press is this replay button, the big center button right here. It'll allow us to get back into the equation. And so you can see how the cursor is all the way over to the left-hand side. So let's go ahead and cursor over to that plus sign. And we want to change that. We want to change that to a minus sign now. And let's go ahead and press equals. Everything else is the same, and it gives us the next answer, 42. So that's the other number of weeks that are going to end up being the same. So let's find out what those values are. So we have to substitute these two values back into the equations. Y equals 50 times by 78, and then plus the 65. And so when we do that work, we end up getting 3,965, and then we do the other one. So it's y equals 50 times by 42, and then plus the 65, and that value gives me 2,165. So these are the two amounts. At, we'll say, 78 weeks, profits were $3,965, and at 42 weeks we had profits at $2,165. So those were our two amounts. Let's try one more here. The population of two different cities are modeled by the equation shown below. Populations are in thousands. Okay, thousands represented by y. So y is going to be population in thousands, and it says the number of years since 1970 is represented by x. Okay, a little different here. Number of years since 1970 is represented by x. What do the cities, or what years do the cities have the same population? What were the populations in those times? Okay, so let's go ahead and do the same thing. I'm going to multiply by -1. It's going to adjust these numbers, the signs at least, and I'll write them underneath the terms I'll collect with. So I'm left with 0 equals x squared. And then here I have to add these two again, so -77x. And then adding these two numbers together gives me a 0, a 10, carry a 1, that makes 13, so 1,300. And so I go ahead and use Pythagorean theorem again. You could probably, or not Pythagorean theorem, but quadratic formula again. You could use factoring, but it'd be kind of tough. So I'm going to just choose to do that, and here's how it sets up. X equals, I've got 77 plus or minus the square root of 77 squared minus 4 times by 1 times by 1,300, and then big fraction bar underneath the whole equation, 2 times by 1. So I substitute the numbers in. Let's go ahead and do that work. Find out what it is. So I'll clear that last one, set it up again, press the fraction button, enter the numbers. Let me clear or move my screen here so I can see what numbers I'm to enter. So it's 77 plus, I'll start off with the plus, then the radical sign, and then 77 squared, and then I'm going to press the minus. I'm going to use parentheses just to overuse parentheses. It doesn't hurt to have extra grouping symbols in there. 4 times 1 times by 1,300. And then close those parentheses. I'll move down into the denominator, just put a 2 down there, press the equal sign, I get 52. Alright, so I'm going to write that number down. So 52 is the first one. Now remember, X is the number of years since 1970. So what I'm going to end up having to do for this is have to go 1970 and then add the 52 to both sides. So this is going to give me 2022. So it's in the future there, and the population will figure out what that is. This is year 2022. Let's find out the next one real quick, and then we'll figure out what the Y value is. So let's go ahead and press the replay button. Brings the cursor back to the center here. There it is. And I'll cursor over to that plus sign before the radical sign. Delete that, change it to subtraction, press equals, and I get my next value, 25. So 25 is the next one, but remember, that is years in the future. So I need to add 25 to 1970. That gives me 1995. So 1995 was the next year. So now I'm going to go ahead and find out what those populations are. Let's go ahead and use probably this the Cryer's port equation, and I've got this y equals 55 times by, and then my x value was 52 minus 950. So that's one of them, and when I do that work, I end up getting 1,910,000. Wow, lots of people in the towns at that time. And then the next one was y equals, and then I've got 55 times by 25, and then minus the 950. And when I do that work, I end up getting 425,000. So that's how many people were in 1995. So in year 1995, there were 425,000 people. And in the year 2022, there are going to be 1,910,000 people. So those are types of problems that you're going to end up seeing on tonight's assignment. Good luck.